They're nice dogs.
Hey guys, how we doing? We are on section 4. We're moving along.
That's right.
Yeah.
Getting through it.
Does it look like we're out in the outback or
Yeah.
safari or something? We're out here camping. It's summer, and so, but hey, we're dedicated to you guys, and so we're always working.
That's right.
So we're talking about measuring and classifying angles, and you've seen angles for years, probably
Yep.
in school, and so we're just going to be very specific with them, is all. And talk about a specific definition of them and how to label them and so on. So we've talked about rays, and so if we take two different rays and give them a common endpoint or the same endpoint, then they form an angle, and that really is the formal definition of an angle. And so in this particular case, we have ray YX and ray YZ. They share Y, the point Y, both the endpoint of those two rays, and so that creates an angle. Okay, and that point Y, the point that they share, is called the vertex. And we talk about vertex on every shape, every chapter,
Yep.
pretty much. So we
Yep.
go through, everything has a vertex to it.
Yep.
And so when you talk about the plural of that, it's not vertexes, it's vertices. And so when we talk about more than one, like in a octagon or something, the vertices of the octagon. And so that common point is called the vertex, and the two rays are the sides of the angle. And so what's very specific here, though, is how you name an angle.
Right.
Always.
Always.
Yeah. And it can go backwards, kind of, but what's critical is the middle point. And so as you look at this, the blue, green, blue here, side, vertex, side, it's critical that the vertex be in the middle. That's the whole naming scheme to angles. The vertex has to be the middle point that you name. And so we could name this angle, angle XYZ, as long as the Y is in the middle. We could name it ZYX, the other way around, but again, notice the Y is in the middle. So those are the two different names. We could go backwards of each other, but the Y has to be in the middle. And when it's an angle just like this, when there's just one angle in the diagram, not that there's some other ray coming out of the middle of it, then it is okay to call it just angle Y. That's all right. We normally label angles with 3 letters, but when there's only one angle, we could label it with 1. Anything else on how to remember to make sure you keep that vertex in the middle?
No, it's just like they've dealt with parabolas, and we talked about the parabola is the part where it swings back up, or the other direction, and same thing with an angle. You guys have seen vertex before. Just the middle or the vertex is the focal point of any angle, guys, and it's just a matter of getting used to it. It should be fine.
Yeah. Just make sure you keep that vertex in the middle of the name.
And also remember that I don't know if it covers on the next slide or not, but opposite rays are still an angle, right?
Yes. Yeah. I think it is on the next slide.
Okay.
Yeah. So. No, the next one, I believe.
But this addresses what you were just talking about a few minutes ago about when with that ray coming out of the largest angle in there. You can't just call this angle X because there's 3 different angles that X could be.
Right.
And so you have to be really careful here, guys, that when you see this kind of a diagram where there's multiple angles within one large angle, that you label this correctly. Because when I look at this, I see 3 angles, and there's YX or WXY on top. There's YXZ on the bottom, and then there's angle WXZ all the way through.
The big one.
Yeah, the big one. So you got to be real careful here. We cannot call this angle X, because my question to you would be, well, which one are you talking about?
Right.
And so just be real careful here that you understand the dynamics of naming an angle and when you can use a single letter or when you have to use all 3.
Yeah, I don't know what's going on with the question there. I think the diagram's on top of it for some reason on the slide, but it should say name the 3 angles in the diagram is all.
Whoops.
So as Mr. Bedell just named them all, but you could name them backwards too.
But notice, guys, like Mr. Scritchfield said on the previous slide, what letter is always in the middle? And every single one of those angles, that X, that vertex, is always in the middle when you name each of those 3 angles.
Right. So the 3 angles are just named either WXY or YXW. And so they named all 3 of them 2 different ways, backwards and forwards. So. Okay.
And then you should not name any of these angles X, because all 3 angles have X as their vertex. And so we kind of cover that, but that's just another glimpse of the same idea.
Yeah, you wouldn't know which one you're talking about if you don't have the other points in there. So, and I don't know when we first cover this, 4th grade?
Yeah.
I don't know. You've heard these terms for years now. And so different types of angles. So we're classifying angles by their measurement. And so an acute angle is not a good looking angle. It is an angle that's less than 90 degrees.
Little guy. He's a cute little
He's a
guy.
cute little angle.
Little
There
guy.
he is. Okay. So anything less than 90 degrees, we call it an acute angle. Okay. A right angle is exactly 90 degrees.
Exactly 90 degrees.
Always equal to 90. And the most common angle that we talk about, just like you were talking about
Yeah.
the other day, is in a room.
Yep.
When we talk about the two walls meeting in a corner, that's a 90-degree angle.
And in geometry in general, it's the most important angle we really discuss.
We spend a lot of time on right angles.
Lots of stuff on right angles, guys.
Yeah.
So, get ready for those.
Right triangles.
Yep.
Yeah. That comes up a lot.
Trigonometry, all that fun stuff.
Yeah. Yeah. And so there's a right angle. And we normally mark a right angle with a little box in the corner to designate that it is a right angle. To designate that these two are perpendicular to each other. So you call that something.
The package.
The package.
Yep, look for the package.
Not sure I wanted to go there, but... obtuse. An obtuse angle is greater than 90, but it's less than 180. And so acute is less than 90, obtuse is bigger than 90 or greater than 90.
It's obtuse. It
Obtuse,
sounds large when you
yes.
say it. It
Obtuse.
sounds large,
Sounds
obtuse.
German or something.
Yeah.
Yeah.
So that's what always, whenever I hear the word obtuse, it just makes me think big.
Yeah.
But it's less than 180. Don't forget that part.
Yeah.
If that angle was 270 degrees, we wouldn't call it 270 degrees. We would call it, 120 or 130.
Yeah, we don't, really in geometry, we don't spend much time on angles bigger than 180.
No.
And so, really, we're only talking, if it's between 90 and 180, it's obtuse.
But if it's 180, is it obtuse?
No,
Okay.
it would be straight.
So make sure you see that difference, guys. Okay.
Now, this is kind of a weird one sometimes.
Yeah.
We don't understand how you even call that an angle. It's just a straight line. And we don't use this a lot.
Nope.
This doesn't come up a whole lot. But we just need to know that if it is a straight line, if it is 180 degrees, it's called a straight angle. So, and we would call it, again, we don't normally refer to it that way.
No.
Angle ABC. But if they were asking you to name that straight angle, that's what you would call it.
Yeah.
So-
If they ask it for it as an angle, you would
Right.
call it angle ABC.
Right.
Now, could you call that just angle B?
You could. You could. Again, it doesn't show up very
Yeah,
often,
and I
but you
just
could.
wanted, it popped
Yeah.
in my head there. I don't know.
Yeah, you could, but it would be kind of strange. But yeah.
Okay, so we want to use a diagram to find the measure of the indicated angle, then classify the angle using the protractor?
Uh-huh.
And so I always forget the name of that thing. But anyway, so if we wanted to find the measurement of angle KHJ, okay, we would look at the protractor there, and you want to follow it from K down to H and up to L. Now, if you look at that, I mean, if you just
Over to J.
over to J. Sorry,
Yeah.
if you were to look at that, okay, and if you use your fingers to kind of help you, you can kind of help yourself by saying, okay, I know that's acute, so I have to pick the smaller number on the protractor,
Yeah.
which in this case is 55 degrees. And so just be careful there, guys, that you use your fingers or use something to help you recognize whether it's acute, obtuse, right, or straight.
So kind of estimate it in the
yeah,
first place.
exactly.
Yeah.
That'll really give you some important insights there. And so it's an acute angle. Then we look at GHK. So if I look over at GHK, now GHK kind of goes back like this. So now I can tell that that's definitely obtuse. So I look at the larger number on my protractor, which is 125 degrees, and so it's obtuse. Then,
So you got to get those scales down.
yeah,
There's a big, there's one scale on the outside, one scale on the inside. And so exactly what Mr. Bedell is talking about, you got to figure out which scale you're using based on whether it's acute or obtuse.
it's okay to have visual,
Yeah.
cues there, guys, or little things to help you out.
Mhm.
GHJ. So once again, I go over to GHJ, and now GHJ just goes all the way across right there. So don't call this 0 degrees because it's not. Okay, I know it's on 0 on one side and on the other, but this is 180 degrees. We just talked about that on the previous slide.
It's a straight line.
Yep, so
Yep.
it's a straight angle. And then we have GHL, and I'm guessing it's going to be a right angle. So if I look at GHL, here I am right here. I can just go straight up and down with my fingers, and it's 90 degrees. Doesn't matter which way you swing it, okay, it's still 90 degrees. I mean,
Yeah.
Get familiar with those 90-degree angles, guys. You're going to see them a lot.
Get familiar with a protractor.
Yeah,
You know how to use a protractor.
Yep.
And you should have used them in earlier classes, but we will spend some time on class. And we don't do this a ton.
No.
We don't measure, physically measure angles a lot. Typically, the problem just gives you what one of them is, and you figure out what the others are or whatever. But sometimes we do measure them, just not very often. And here's an example of that.
Yep.
They're giving us some particular information in here, and we need to come up with some of the angles that they're asking for. And so right now they're asking for angle fun, F-U-N. And so now you need to be careful in this diagram because it's not 97 degrees. It looks like it maybe because the 97 is inside that small angle right there. But you need to look at the fact that the blue arc there across that angle is really what the 97 is referring to. Maybe that 97 should be a little bit lower to where it's close to that blue line.
But even still, I mean, if you look at that, you should be thinking in your head, wow, you know, that doesn't look like 97 degrees, that little piece.
Yeah.
And so you really got to think that can't be right. And so you got to look and then recognize, you know, the red arc there and then the blue arc there and say, okay, so the red arc's got to be 62 and that blue arc has got to be 97 from all the way around there.
Yeah.
So just be careful with that.
You have to be careful. We don't want to assume too much from a diagram.
That's right.
We always want to use the given information.
That's
but,
right.
but that diagram is saying that blue angle is 97 degrees, which would be angle BUN, B-U-N. Okay? So because they give us the big one, 97, it's just like what we talked about with segments. Because they give us the big one and they give us a smaller one inside of it, a part of it, we can subtract those two in order to come up with the other part. So if the big angle is 97, part of it's 62, we can subtract those two and get 35, and that's what the angle FUN is that they're asking us for in order to come up with that answer. And so these are all going to come in on their own, aren't they? So there it is, 35 degrees for angle FUN. Okay, I'll grab the.
Now, if we look at angle
grab the butt.
angle BUT here, but if we look at the measurement for angle butt here. You could do this a couple different ways. I mean, it just, to me, when I look at this, I see that angle BUS is a straight angle, so I know that that is 180 degrees. And then angle TUS is 18, and then angle BUT is the rest of that. So if I just go 180 minus 18, that leaves me with 162 degrees. Or what I could have done is say, okay, I know from BUS is a straight angle. I know that FUB is 62. I know that BUN is 97, and I know that TUS is 18. If I add those two together and then subtract that from 180, that will also tell me the remaining piece for the measurement. Wait, no, that won't tell me the measurement for angle butt.
It'll give you NUT.
Yeah, it'll give me NUT, and then I could add that back in.
Yeah, it'll just be a little bit longer.
A little bit longer, but I mean, some kids see this in a lot of different ways, but you know, it's 162 degrees.
Usually when you have a diagram like this, there's multiple ways of getting the answer, a shorter way and then typically a longer way, and so, but you could do it whatever.
Yep. So
angle NUT, what we were just talking about, we could figure that one out based on if BUT now is 162 degrees, we just figured that out. Part of it was the FUN one, so part of it is 97 degrees. We could just subtract that 97 from the 162, and what would we get? 155, 65, wouldn't it be?
Yeah.
155 minus 90, and so I believe NUT is 65 degrees.
And then if we wanted to find the measurement of cub, which is down here on the left, now there's a cheat through here. I mean,
we haven't gotten there yet.
We haven't gotten there yet, but
yeah.
There's this rule called vertical angles, which says if angle TUS is 18 and they're two straight lines, then angle BUS is its vertical or its opposite, and it is also 18. But we're not supposed to know that. So what you're going to have to do instead is you could recognize that if this is 18 degrees, you know, all the way over to here is 180 degrees. So I could go 180 minus 18 gives me 162. And so now I know that this angle CUS, sorry, you can't see what I'm pointing at. Angle CUS is 162 degrees. Well, if I look at the bottom half of angle BUS, I know that's 180 degrees. I could just subtract that 162 from 18 or from 180, and that gives me back to my 18 for angle cub.
Right. And so yeah, so maybe it would be to an advantage to find CUS first, which is what Mr. Bedella just did, and then find the CUB one.
And I think
you have to do that sometimes.
Yeah.
You got to work your way around the diagram, whatever way you have to do to find the pieces. And you know, for a diagram like this, sometimes it's easiest just go in and find all the pieces first, and then figure out what questions they're asking you, especially when there's this many.
And later on, guys, as part of your homework assignment, you're going to have to do another one of these.
Mm-hmm.
So my advice to you is if you really didn't understand this and went too fast, pause it and just look at it and see if you can figure out those measurements on your own. Figure out your own way to come up with those answers right there, so it makes sense to you. This is the bonus of these videos, is you guys can pause these and take some time to get used to it, and help yourself out a little bit.
So when you get to that one, you may need to come back to this one for an example. Okay, so hopefully you got that, but we're going to do many more like this. So, okay, and this one's similar, but it actually throws in some algebra now.
Yep. So if we're given that the measurement of angle LKN is 145 degrees, and we need to find the measurement of LKM and the measurement of MKN. Okay, so what are we going to do? Well, they tell us that LKN is 145 degrees, and so that is the whole angle, guys. That's the large angle, okay, all the way across that. And so we know that that whole thing is 145, and we know the two smaller pieces are algebraically written as 2x plus 10 and 4x minus 3. Well, just like we have the segment addition postulate, we can also apply that to angles and kind of have an angle addition postulate and say that, okay, this part angle plus this part angle equals the big angle. So part plus part equals whole comes back to play again. And so all I got to do is go 2x plus 10 plus 4x minus 3 equals 145. Or they set it up, you know, with all the vocabulary first there. But there it is right there. And then all you got to do is combine like terms, move things around, and you get, you know, 6x equals 138 after you do some addition and stuff, and then divide that through, and you get x is 23 degrees. Now, remember,
there's another one.
Just like on the segment addition postulate thing we did, that's only x. They don't tell us to find x. They tell us to find the measurement of LKM and the measurement of MKN. So you got to go back, plug things in. You could plug x in twice, or you could plug x in once and subtract the one you get from 145, and that'll automatically give you the other one. Let's see the way they do it here. So they plug it into 2x plus 10 first, so 2 times 23 is 46, plus 10 more is 56, so LKM is 56, and to find MKN, they plug it in again, so 4 times 23 is, 92, and then minus 3 is 89. Or you could have just said 145 minus 56, that also gives you 89. Either way it works.
Either way, yep.
So hey, that's the greatest thing about geometry, guys, is a lot of these postulates we're going to learn early on repeat themselves over and over again, so you can apply them across a lot of different visuals. Or ideas, concepts.
That's a good question right there. You need to know how to do that one.
Yep, and it's coming up on the end of the PowerPoint that you're going to solve some of those on your own.
Angle bisector. So just like we had a segment bisector, by 2, sect, cut, cuts it exactly in 2 equal pieces. And so when we're talking about an angle bisector, it is another ray in the middle of the 2 rays that make up the angle that cuts it exactly in half, cuts that angle exactly into 2 congruent angles. So these 2 angles, angle 1 and angle 2, or angle ABD and angle CBD, those 2 angles end up being congruent to each other if they tell us, and they do have to tell us, that BD bisects that angle.
And notice how they do the hash marks for angles here, guys.
Yeah, we had hash marks on segments, we have hash marks for angles.
And as you have multiple, we didn't even talk about that, as you have multiple pieces that are congruent but different, you can just add more arcs to the arc.
Right, so you could have 2 arcs on one, 2 arcs on the other, you know, right next to each other to show that those 2 angles are congruent, in addition to the ones that just have 1 hash mark on them. And we'll have diagrams like that as we progress.
It's a real easy thing to get.
It's just notation.
Yep.
Okay, so an angle bisector, you need to understand that concept. It's a ray or a line that bisects an angle.
So part equals part.
Yep. So now we're getting the ones we're talking about.
Yeah, so here we have some part equals part. And so it says BD is the angle bisector. So pretty much, guys, you know, if DBC, this is
one where we're asking them to do it.
Yeah, so if you know what DBC is, you should be able to understand what a bisector is to figure out what ABD is, and then go through and do the math and kind of make some assumptions and do some calculations, real easy stuff to figure it out.
Right, and so since we didn't do one exactly with a bisector, and we'll give you a couple hints here. If DBC is 42 degrees, and that's an angle bisector, then that top angle has to be the same thing, right? And you would double it to get the big angle.
Yep, then just do part plus part equals whole.
Yeah, and so you can go through and get these. It's not a massive question there. So pause it here, get your answers to that to show us in class tomorrow. And similar.
Yeah, here's another thing. Now they just take it algebraically.
Kind of like that one you did.
Yeah, so basically, guys, it's the exact same thing as the previous slide, but now it's set up algebraically, and we know those are equal. So if things are equal, what do?
we set them equal.
We set them equal. So just work
Solve
through
it
that.
algebraically
there
and
you go.
come up with x, plug into both angles, or once you know one, you know the other,
Yep.
because it's a bisector. And so plug into the easiest one and get them both.
Yep.
And I believe we have one more. Now this is that one you're talking about.
Yeah.
This is that one like we did before with the different angles and so on. And so they're asking you for 4 different angles here. And so you may have to rewind to that one that we talked about and use that as an example, but we want you to be able to come up with these 4 angles out of that diagram right there.
And really, if you get this, I think you get this whole lesson.
Absolutely.
If you can do
this
this,
summarizes the whole thing.
Yeah, if you can get this, guys,
Yeah.
it's pretty much you're shoo-in for understanding this stuff.
Now I'm noticing a major clue in this one.
Yes, I see the package.
Yeah, it's there. So be careful with that.
Remember what that means.
Yeah. So, all right.
All right.
Okay, guys. We'll see you in class.